Today we will introduce a demonstration system to you, the PEM electricity, water hydrogen production and storage demonstration system. First, we add purified water to the water tank. And then we can tap the start button. The water passes through the resin by the water pump and then to the electrolyzer. Here is a flow meter used to monitor whether there is water passing through. If no water is detected, the electrolyzer will stop working. This is the power supply used to supply power to the electrolyzer. Then the electrolyzed oxygen follows this pipe back to the water tank, and the hydrogen follows this pipe to the moisture separator. After separation, it reaches to purification device. The first stage of purification is color-changing silica gel, and the second stage is molecular sieve. Their function is to absorb the water molecule in hydrogen. This is a T-type filter whose purpose is to filter out dust. Next down is pressure sensors that monitor the pressure from the electrolyzer to the molecular sieve. This is a ball valve that controls the entire hydrogen flow. Looking backward, it is a check valve to ensure that the hydrogen doesn't flow back. Finally, hydrogen is stored in the hydrogen tank. This is the entire process. It should be noticed that the TDS value of the water in the water tank should be controlled below 5, and the resin and the purification device are consumables. It recommended that the resin be replaced when the water TDS value reaches 3, and it is recommended to replace the color-changing silica gel after it has changing color. Next, I will introduce the entire process of the hydrogen fuel cell power generation demonstration system. When the system starts up, the operator needs to press both the spring start button and the battery start button concurrently. The lithium battery provides the initial power to make the system run. And then the hydrogen stored in the solid-state hydrogen storage cylinder flows successfully through the pressure-reducing valve, ball valve, solenoid valve, and T-type filter, and then enter the fuel cell module for the electrochemical reaction to generate electricity. The electricity generated by the reaction is transmitted to the voltage stabilizing module for voltage regulation. The stabilized power is then supplied to the electrical control system to achieve self-sustaining operation of the system. Meanwhile, the water vapor generated by the fuel cell reaction and the small amount of the exhaust gas are discharged through the exhaust valve at the bottom at a cycle of once every 7 seconds. At this point, the system has completed the entire closed-loop process from start-up, hydrogen supply, power generation, power voltage stabilization, and self-supply to the discharge of byproducts. And this is control screen of the system. This is current, and this is voltage, and output power and inlet pressure to stack.